Salam all. So we are going to proceed with the more instructions. So today the chapter will be talking about the bit manipulations. So part of it is a Boolean instruction. If you can remember that this is basically taught in your secondary school on the gates about the AND or exclusive or not, which is the one that we are going to implement and use it today. So so far there's not so much syntax on the Boolean instructions. So according to this page, we only have how many of them? 1, 2, 3, 4, 5, 6, 7, 7 commands. And you can see that and we have both and immediate. Same goes to or immediate, exclusive or immediate, and the last one is not. So if you can see the pattern here, if you have the immediate and instruction or instructions or exclusive for instruction for immediate, so you have actually a data over here which is a number, okay, the number. Whereas if you don't have the immediate, you need to find out where's the source effective address and your destination effective address. So we're going to look at the examples after this. Okay, before that, let's go back to the theory of the booleans, the instruction for the the operation for AND, or, exclusive or, and not. So if you can remember, last time when you learned in your primary school for your science subject, so you only have you have two input, right? So there will be an output over here. So this input, you only have two inputs, so you know that from these two input you can put like this, the input. And for AND operation, N is going to be 0, 0 will be 0, 1, 0 will be 0, 0. Sorry, this is 1. Sorry, this is 1. So this is 1. So this is 1. Okay. So let's say for the OR. So AB again. So you have a 0, 0, 1, 0, 0, 1, and 1, 1. So for OR, right, for OR, this is 0, this is 1, this is 1, and this is 1. Okay. And then for exclusive OR, you have also A and B, and you have the output Y. So again, I just use this one, it should be okay. So for exclusive OR, so only for the exclusive OR is going to be 1. So this is going to be 0. This is going to be 1. This is going to be 1. And this one's going to be 0. Because it's both got the same numbers. And the last one is not. Not is only one input. So you only have to have one input. So no matter what, A, the next one will be the invert values of that. So in case of, for example, the value is A, 1 for A is 1 is for A, and the result will be 0. Okay, so this is basically the results, or the table, the truth table for the operation for AND, or exclusive OR, and not. So let's look at the command, how it works. So for AND operation, what does it mean here? For AND operation, you need to know what's the size that you want to have. This is the size like for the byte, and for the word size, and the long word size. Okay. So what does it mean that if you do the AND instruction, it will erase certain bit in the destinations. Source operand will act as the mask which determine which bit to be erased. Which means that if you have the input as 0 here, it will erase anything from the output. So if you have 0 part of it, so of course your result will be all here will be 0. Sorry, this one. Okay, so if you have the value, part of it is 1, So it will keep the current bit value in the destination. So if you have anything is 1, so the final destination will always be 1. So that is actually the n.size effective address to a data register, or n address.size from data register to effective address. So for the case of n immediate, you still have the size here, but you have to put the value, which is going to be the bit number, which is a hash, to the last one is effective destination, effective address. So now look at here. This is actually a question, erase all bits in D0 except B0 to 3. So D0 contains, this is the value for D0. Okay, so let's try to look at this one. Okay, n immediate long words hash $F. Okay, comma D0. So this is the one going to be the act as a mask over here. They call it as a mask, should be this one. So you have this one A, and you have that operation for B. So A and B will be resulted like this. So D0 for the long word. Long word means that you have to take everything here, right? So A is equivalent to this one, D is equivalent to this one, 2 is equivalent to this one, B, and the rest is 0. So this is F. This is F. So the question is erase all bits in D0 except B0 to 3. So this one is bit 0 to bit 3. You want to erase all means that you have to put all 0 except this one is going to be 1. So the command will be like this. So if you put 1, the value will always like this, will always have the same one. Whereas if you put 0 all, it will all erase the value here. So this is going to be the same result from the input. So finally, you can get that this is the initial value, B to DA, and finally you can get this value, which is all 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0 is A. So that is the result for the n immediate. Okay, next one. OR instruction. Okay, just now we have the OR. OR instruction, like for example A and B here, and Y, which is 0, 0, 0, 1, 1, 0, and 1, 1. So this is 0, the rest is all 1. Remember that? So what does it mean? That all instructions set certain bit in the destination. Set means 1. Set is equivalent to 1. Certain bit in destinations. The bit is selected by source operand. So value 1, if you have value 1, you will set the bit in destination. For example, that if you put 1 here, the result will be 1. So if you put 0, right? If you put 0, the result will keep the value in the first one here. Here, let's say for example, if you have 1 here, if you have 1, then you have the result will be 1. If you put 0, you will always going to have the same value for the input. Okay, so same example, same assembly syntax, like for example, word size, or this is the size, effective address, comma, destination, or the size address or destination, data registers to effective address. So the or immediate, also we have the value here to the effective address. So let's look at the example that we have. The question is set the bit 5 to 7 in D0. D0 is given like this one. So bit 5 to 7. So we convert this one to binary numbers. So this is all the bit numbers. D is this one, 2 is this one, 2 is this one, and A is this one. Okay, the question is set the bit 5 to 7 in D0. So what does it mean? That the question wants bit 5 to bit 7 all equivalent to 1. Okay, so right now you have to calculate this one. This is a bit 0, bit 1, bit 2, bit 3. Okay, this is 4. 0, 1, 2, 3. Oh yeah, this is 4, this is 5, 6, and 7. So the question is set the bit 5 to 7. So it means that you have to give 1 from the mask over here. So this is 5 to 7, or you give 1. So you're going to set any values. I mean, whatever the output, if you put 1 here, the result will be 1 here, which is set bit 5 to 7 in D0. So the rest, you just need to put 0, because no matter what number, with any number with 0, for all operation, it will result back the values, the initial values here. So this is the value that changed. So if you put all 0 and this one's only 1, you can get all this one A, the same one. This is 2. This is the value different one. This is E. And this is still maintained as D. So this is the result. Okay, next one. Exclusive OR. Same thing, you can see that, but the definition is if you put 1, so let's say for example A and B just now, A and B and Y, so you have 0, 0, you have 0, 1, you have 1, 0, you have 1, 1, so this is going to be 0, this is 1, this is 1, this is going to be 0. So if you have value 1, you see this one, value 1, you will complement the bit in destination. So if you have, this is for example, this is going to be the exclusive OR, right? If you give 1 here, you will complement. Complement means it's going to shift. I mean, change it from 0 to 1 or 1 to 0. Like for example, in this case that you have this 0 and then you have 1, you are going to complement to from 0 to 1. This is the correct complement. Okay, complement ialah melengkapi. So for example that people say that you are complementing my life, something that you are mencukupkan diri saya. So it's actually going to be melengkapkan macam tu. Alright. So now if you put 0, here, for example, here. Again, before that, you just look at over here, the 1. So you can see that this is a value initial, then it will going to be complement to 0. If you put 0, you will keep the original bit in destination. So if you put 0, the value will be the same. Okay, that's the meaning of whether it is complement or keep. The syntax is the same. Exclusive OR dot size, effective address at the data register. Exclusive OR with the size, data register with the effective address. Exclusive OR immediate with the size is hash value and the effective address. Okay, so let's try to look at the questions here. Example, complement. Complement means you have to change the value from either from 0 to 1 or 1 to 0. So complement bit 8 to 15 in D0. Okay, D0 contains A, 0, A to D. So you have to convert all of this first. This is D. This is 2. This is 2. This is A. Because of this is only word size, so I don't really care the rest. Okay, complement bit 8 to 15. So you need to find out where is the bit 8. So this is bit 0, 1, 2, 3, 4, 5, 6, 7. This is the one starting for 8, bit number 8. 9, 10, 11, 12, 13, 14, 15. So the last one is bit 15. Okay. So this is a bit 15, right? So this is bit 15. So you want to complement. Complement means just now you have to put 1 down here. So this is all the one value that you are going to put. Complement means you are going to change the value. The rest, if you put 0, is going to be the same one. This is going to be D. This is going to be 2. So you are complementing 0, 1 is 1. The rest you can get this answer. And this is going to be 5. And then this is going to be D. So this is a exclusive OR operation. Okay, next. NOT is very easy. NOT the value, the size of the value, and the effective address. So that's a very simple one. Let's look at the example. Complement byte in D0. Complement means actually you are going to have a NOT operation. Means everything is going to be changed accordingly. Is complementing. So complement byte size byte in D0. D0 contains A to D. So not the byte D0. So it's going to be 2D only. So this is going to be 2. This is going to be D. You have this value. So you're going to convert it. You are going to complement it. So finally you can get this is the value for D. And this is going to be 2. So this is the latest one on the byte results. Because this is a very simple NOT. Okay, that's the operation for the Boolean. So it's very simple. You just need to know the truth table. And then you can simply get the final result for it. Okay, that's for the first one.